We look up at the night sky. Countless stars pepper the darkness. Could there be life out there? Could there be other beings looking back at us, asking the same questions? It's a call to explore, to push the boundaries of what we know and where we can go. This is the cosmic call of space exploration. Space, in all its vastness, represents the ultimate frontier. Space colonization, the concept of establishing permanent human settlements beyond Earth, is no longer science fiction. It represents a natural progression of our exploratory spirit, a chance to secure the future of our species. Our planet Earth is a beautiful and fragile oasis in the vastness of space. We see it in images from distant probes, a tiny blue dot against the backdrop of the cosmos. This pale blue dot, as Carl Sagan famously called it, is everything to us. But it's also finite. We face challenges on Earth. Space colonization offers a safety net, a backup plan for humanity. By establishing a presence on other worlds, we can mitigate these risks and ensure our long-term survival. Just imagine the discoveries that await us on Mars, on the moons of Jupiter and Saturn and beyond. The journey won't be easy. Space is a harsh and unforgiving environment. We'll need to overcome numerous technological hurdles, from developing sustainable life support systems to finding ways to protect ourselves from radiation. But the human spirit is one of ingenuity and resilience. We can overcome the challenges of space colonization too. The rewards are simply too great to ignore. The future of humanity could be one of interplanetary settlement, where we become a multi-planetary species. Imagine future generations living on Mars, mining asteroids, and maybe even journeying to distant stars. When we think of colonizing space, one celestial body consistently captures our imagination: Mars. Our rusty red neighbor, named after the Roman god of war, holds a unique allure. It's a world of stark beauty, with towering volcanoes, vast canyons, and polar ice caps. Unlike the scorching heat of Venus or the crushing pressure of Jupiter, Mars offers a somewhat familiar environment. While Mars today is a cold, arid desert, scientists believe it may have once been a warmer, wetter world, perhaps even capable of supporting life. This tantalizing possibility fuels our desire to explore it further. While Mars presents a compelling opportunity for colonization, it also poses significant challenges. The Martian atmosphere is extremely thin, about 1% as dense as Earth's, offering little protection from harmful solar radiation. The average temperature on Mars is a frigid -63 degrees Celsius. Getting to Mars with current technology takes about 7 months, a long journey fraught with its own set of risks and unknowns. Establishing a permanent human presence on Mars will require overcoming these obstacles. We'll need to develop innovative ways to protect colonists from radiation, perhaps by building underground habitats or utilizing Martian resources for shielding. Creating a breathable atmosphere, either within enclosed structures or through terraforming efforts, will be crucial for long-term survival. But just as our ancestors overcame challenges on Earth, we too can rise to the occasion. One of the most ambitious and intriguing aspects of colonizing Mars is the potential for terraforming. Scientists believe it might be possible to engineer the Martian atmosphere, warm the planet, and eventually create a more hospitable environment for humans. This process would involve a long-term commitment, spanning generations. One idea involves releasing greenhouse gases into the Martian atmosphere to trap heat and trigger a runaway greenhouse effect. Terraforming Mars is a monumental task, but the potential rewards are enormous. Imagine a future where Mars is no longer a red, dusty desert, but a vibrant, living world with flowing rivers, lush vegetation, and breathable air. Reaching for Mars and venturing further into the cosmos demands a revolution in spacecraft technology. Colonizing Mars necessitates vessels that are not merely transportation, but self-sustaining ecosystems hurtling through the void. Imagine enormous spacecraft, dwarfing the International Space Station, assembled in Earth orbit or perhaps even on the lunar surface. These wouldn't be sterile, metallic boxes, but rather rotating habitats, mimicking gravity through centrifugal force. These interplanetary arcs would need robust radiation shielding, perhaps utilizing water ice, a resource abundant in space. Advanced propulsion systems, far surpassing current chemical rockets, will be essential. Stepping onto Mars, we encounter an environment hostile to life as we know it. The thin atmosphere, lack of liquid water, and exposure to cosmic radiation present challenges that must be overcome to establish a permanent human presence. Life support systems, far more sophisticated than those used in current space missions, will be paramount. Closed-loop ecosystems, mimicking Earth's natural cycles, will be essential for long-term sustainability. Imagine hydroponic farms bathed in artificial sunlight producing food and recycling waste. Water, a precious commodity, will be meticulously collected, purified, and recycled. The psychological well-being of Martian colonists will be as crucial as their physical needs. Establishing a thriving colony on Mars requires a reliable and sustainable source of energy. Solar panels face limitations on the Red Planet due to dust storms and the weaker sunlight. Nuclear power, with its high energy density and reliability, presents a compelling solution. Small, modular reactors, designed for safety and efficiency, could provide a constant source of power for Martian outposts. These reactors would power life support systems, illuminate greenhouses, and drive the machinery needed for resource extraction and construction. Harnessing Martian resources will be crucial for long-term sustainability. In the unforgiving environment of Mars, robots will play a crucial role, not just as tools, but as partners in colonization. Autonomous rovers, equipped with artificial intelligence and advanced sensors, can scout ahead, map the terrain, and identify resources. Robotic construction crews can assemble habitats and infrastructure before humans arrive. Imagine robotic miners, tirelessly extracting water ice and minerals from the Martian soil, or robotic farmers tending to vast fields of genetically engineered crops. These mechanical assistants will not only alleviate the workload on human colonists, but also allow us to explore and utilize the Martian environment in ways that would be impossible for humans alone. This collaboration between humans and machines will be essential for the success of Martian colonization. As we venture beyond Earth, a profound ethical question arises. What right do we have to colonize other planets? Some argue that space, like the high seas, should be a global commons belonging to all humanity. Others raise concerns about potential contamination of celestial bodies with Earth-based life. What if Mars harbors its own unique life forms, perhaps microscopic and hidden beneath the surface? The search for extraterrestrial life, a driving force behind space exploration, takes on new urgency in this context. Before we plant our flag on Mars, shouldn't we first determine if we're stepping into someone else's home? Establishing a permanent human presence on Mars will necessitate the creation of new societal structures and legal frameworks. What laws will govern these Martian settlements? Who will enforce them? The harsh and unforgiving environment of Mars will likely demand a strong sense of community and cooperation. The development of Martian law will require careful consideration of human rights, environmental protection, and the unique challenges of living on a frontier world. Will Martian colonists have the same rights and freedoms as citizens of Earth-based nations? How will we ensure that Martian resources are managed sustainably for the benefit of both present and future generations? Life on Mars will be unlike anything we've experienced on Earth. The lower gravity, the thin atmosphere, the different day-night cycle, and the constant exposure to radiation will all exert their influence on human physiology and psychology. Over time, Martian colonists may evolve distinct physical and cultural characteristics, adapting to their new environment. Imagine generations born under a salmon-colored sky, their bodies accustomed to the lower gravity. Their circadian rhythms might shift to align with the longer Martian day. The challenges of living on a frontier world could foster a spirit of innovation and self-reliance. Perhaps the most profound impact of space colonization will be its effect on our understanding of ourselves and our place in the cosmos. Astronauts who have had the privilege of seeing Earth from space often describe a profound shift in perspective known as the overview effect. From orbit, our planet appears as a fragile oasis, a blue marble suspended in the vastness of space. National borders vanish, conflicts seem petty, and the interconnectedness of all life becomes strikingly clear. As humans venture further into space and establish a presence on other worlds, this sense of the overview effect will likely deepen. By venturing into the cosmos, we might just discover what it truly means to be human. Imagine standing on the surface of Mars, 100 years from now. The sky, no longer the familiar blue, shimmers with a pale salmon hue as the sun dips below the horizon. Dust devils dance across the red plains, remnants of a once thin atmosphere now thickening, a testament to generations of terraforming efforts. Overhead, a constellation of bright lights streaks across the sky, not satellites but habitats. Their inhabitants going about their daily lives, connected by a network of spacefaring vessels ferrying people and resources across the inner solar system. This isn't just a dream, it's a potential future within the realm of possibility. As our understanding of the universe expands, so too does the scope of human ambition. Mars, once a distant and hostile world, could become a bustling hub of human activity, a second home for our species, and a stepping stone to even grander destinations. This future Martian society might be as different from our own as we are from the hunter-gatherers of the Pleistocene epoch. They might develop new forms of government, new social structures, new ways of interacting with their environment. They might even evolve new physiological adaptations to the Martian environment, becoming a distinct branch of humanity, shaped by the challenges and opportunities of their adopted world. But Mars is just the beginning. As our technological prowess grows, so too will our reach into the cosmos. The asteroid belt, a treasure trove of resources, beckons. Imagine mining operations extracting precious metals and water ice from these celestial bodies, fueling further exploration and expansion. The moons of Jupiter and Saturn, with their subsurface oceans and potential for harboring life, offer tantalizing targets for scientific discovery and perhaps even future colonization. This multi-planetary future won't be without its challenges. Resource allocation, interplanetary governance, and the potential for conflict between Earth and its off-world colonies will require careful navigation. But the rewards, both tangible and intangible, are too great to ignore. Imagine a future where humanity is no longer confined to a single planet, where our ingenuity and curiosity have taken us to the farthest reaches of the solar system and beyond. Imagine a future where we've unlocked the secrets of the universe, discovered new forms of life, and expanded the boundaries of human knowledge and experience beyond our wildest dreams. This is the promise of space colonization, a future where the stars are not merely points of light in the night sky, but destinations waiting to be explored. The journey into space is more than just a physical one. It's a journey of self-discovery, a quest to understand our place in the grand tapestry of the cosmos. As we venture further from Earth, we'll inevitably encounter new perspectives, new ways of thinking, new ways of being human. We may even encounter other intelligent life forms, forever altering our understanding of our place in the universe. This cosmic perspective will challenge our assumptions, broaden our horizons, and push us to evolve as a species. We'll be forced to confront our biases, our limitations, and our potential in ways we never thought possible. We'll learn to think beyond national borders, beyond planetary boundaries, and even beyond the limitations of our current understanding of physics and biology. This is the transformative power of space exploration. It forces us to confront the unknown, to embrace the challenges, and to strive for something greater than ourselves. It reminds us that we are all connected, not just to each other, but to the cosmos itself. We are, after all, children of the stars, born from the remnants of supernovae, our atoms forged in the hearts of dying suns. Our journey into space is a return to our cosmic origins, a quest to understand not just where we come from, but where we're going. We stand at the precipice of a new era, a pivotal moment in human history. The journey ahead, to the stars and beyond, will be fraught with challenges, demanding courage, ingenuity, and unwavering resolve. Yet the rewards, the expansion of knowledge, the discovery of new worlds, the potential to ensure the survival and continued evolution of our species, far outweigh the risks. We are a species of explorers, our ancestors driven by curiosity, a thirst for the unknown. Their spirit lives on in us, urging us to reach for the cosmos, to push the boundaries of what's possible. The colonization of space will not be easy, nor will it be accomplished overnight. It will require a sustained, collaborative effort, spanning generations, transcending national boundaries, and uniting humanity in a common goal. But as we venture out into the cosmos, we carry with us the lessons learned on Earth, the knowledge gained from centuries of striving, exploring, and overcoming adversity. We are on the verge of an incredible adventure, an epic tale waiting to be written. It is a future where humanity takes its place among the stars, not as conquerors, but as explorers, as pioneers, as stewards of a universe teeming with wonder and possibility. This is our destiny, to embrace the cosmos and all its mysteries, to boldly go where no one has gone before, and to shape a future worthy of the generations that will inherit the stars.